A very good day to doctor. Okay, today I'm gonna present about power electronic and drives assignment title hybrid energy storage system of electric scooter based on wireless power transfer. And I will thanks to my teammates that Joseph Anandan and Ganadhan and Nabila Usna that giving full commitment to done this assignment. And by the way, my name is Mitran Gopala Krishnan, and I will start with introduce abstract of this assignment. The aim of the paper is to present the design and implementation of the hybrid energy storage system HESS with wireless power transfer to create high performance energy source for electric scooter. These studies combines a battery bank with a supercapacitor bank for testing. The suggested technology may be used on commercial 48-volt electric scooters. To construct the energy of transmission, the discrete technique use the SAE J2954 wireless power transfer frequency standard. This research provide three-mode technique for hybrid energy management based on battery bank state for charge SOC control. Three compact and integrate contribution are made by proposed HESS. The first act as a regulator, regulating the energy intake from wireless power transfer. Second, it's also with the energy location to the battery and supercapacitor. Third is provide a means for initiation a brief period of negative current to prevent the battery from being overworked and add validation after polarization. This feature can be help you get more battery life out of our device. As consequence, the electric scooter system performance may increase on 0.8 kilowatt electric scooter and double-side LCC coil with the 15 cm air gap crate for wireless charging. For the DC to the battery supercapacitor, the entire system offensive is 20%. So
Next, I will present about introduction of this assignment. I like internal combustion engine, which is contribute to environmental issues such as pollution and global warming, and electric motor produce no emission. As a result, electric vehicle look to be one of the greatest public transit solution. Its great energy density and mobility, the battery is an ideal foundation for electric vehicle advancement. Most commercial batteries generate power by electrochemical process, which degrade with time due to the limited polarization mechanism that cause the chemical reaction. Next, the study used a battery supercapacitor to construct the energy source for propulsion in order to improve the performance of traditional electric scooter. Develop a multi-port isolated DC and DC converter for hybrid battery and supercapacitor application that achieve zero voltage switching for all switches over the whole load range. Next, the proposed system. The study offered an electric scooter system with dual energy source. As stated in introduction, both the battery and the supercapacitor are placed in scooter to improve the original system dynamic performance. The suggested electric scooter same layout and call for WBT are shown in figure 2. Between the transmitter and receiver hall, there is a 50 cm air gap. The supercapacitor and battery primary duty is to provide energy. Electric scooter is powered by a fuel cell technology with the help of a supercapacitor bank. According to the same scooter application, they produce energy by electrochemical process, where the supercapacitor store energy through an electric potential. The supercapacitor has a very high density, which compensates for the battery longevity issue with charging or discharging at high current. The density of this battery is 10 times that of standard lead acid battery. Furthermore, the battery lifespan can be increased in the supercharacteristic compensate for the majority of the battery deep charging or discharging operation during application. As a result, the battery will be able to start more electrochemical process operation. Next, I will pass to Dorset to present the simulation part.
Let's move on to ultimate. Okay, now I explain about the calculation for insert value for our simulation. Later my friend will be inserting the simulation. So now for the value, from the can see the first equation, we find out that resistance by the power equation. So we get resistance 2.88. So the V we as a given 48 volt and power as given 800. So we get the resistance. For the second equation, we can see there from so for get L, so we find out Q is we fix 10, R as 2.88, then we get frequency we set for 35 kilo, and L will get 130.96. Other than for equation 3, forget LM, so we substitute our L1 and we consider L2 as also similar, so we'll get LM. Once we get LM for equation 4, okay, so we go for the equation 4 to get capacitor value. So our get capacitor value is 157.89 NF. So we get from frequency equation. So let's we move on to equation 5. Once equation 5 is we assume voltage 1 is 60. Then as a given, as we know, so from that we find out I2. So once we get I2, we go on to get IL2, the current load at second, which means we using the formula we get 0.28, and once we get IL2, we can move on to equation 7 that to get current at current 1. So one we get current 1 in equation 8, so we try to find out the power out. So once it's a power out, we're using the formula L equals to QR 2 pi F, voltage 1 and voltage 2 input. So from that we're using 2.88 is a resistance, and for I2 square we get power out 12.46 volt. Then we assume system ideal for 100%. We using an power out over power in times by 100%. We get power in is 12.46 volt. At last we doing the equation 9 is to get voltage 2. So we using to substitute the value we find out, and we get V2 5.99 volt. So with this calculation we will insert in our simulation. Later we see the simulation circuit. Thank you.
Greetings, Dr. Isma, and thanks, Vikran, for the explanation regarding the calculation for the values that need to be inserted in this method simulation. Okay, as you have know, this is the circuit simulation for the project of our assignment for the power electronics and derives. As we can see here, there are four types of MOSFET used. This is known as a class D inverter, and the rectifier we are using four types of diode. This is known as a full bridge rectifier circuit, and the transmission medium in this wire power transfer is known as the inductive for us. It is the inductive approach, and we are using LC topology where the inductor value are inserted based on our calculation, and the capacitor value is also inserted in our circuit as well. And the residual part also, the values are kept the same as the input side. Okay, and this is our input voltage, which is 60 volts, and here we set the switching frequency, which is at 35 kilohertz. So the period is 1 hour frequency, which is 27.56 to the power of 26 seconds. And at the part 2 here, we inserting a delay, phase delay of half of the period that we got here. Okay, now let me show the initial data. Okay, so you can see that this is the input loss or input switching frequency. There you can see that when one part is high, another is low, and it's already alternating. Next, I'm going to show the this is the input voltage and the input current graph. Then these are the input voltage at the transfer coil, and this is the receiver at the receiving coil, and this is the output of our in desired circuit or our system simulation for this assignment. Okay, that's all from me. Thank you, doctor. Have a good day.
Thank you. As my friend everything explained, now is come to conclusion about this project. This research proposed a HESS energy management approach that power wireless power transfer. It's a design for 48-volt commercial electric scooter, as I mentioned, and as now, in terms of study future work, rectifier work should be not modified an active one, as in result, the function of discharge and regenerative braking may be used. A series of experiential evaluation on lifetime improvement issues on the depolarization function should be carried out. In addition, the compensation circuit for the LCC topology should be modified in light of dynamic charges. The system as might be benefit from all flexible operation. So by the way, on a 0.8 kilowatt electric scooter double side LCC coil with 15 cm gap was created for wireless charger. For the DC supply battery for super capacitor, the entire system FNCC is 20%. FNCC is 20%. Thank you. That's all.